they do in the industry in terms of their career performance. So I had a chance to have my former students, PhD students who graduated 2 years ago, 2024, and she is now in Lixidian, okay? And frankly, her first choice before graduation is Taijidian, but they end up to another company, which I encourage her to go because in less than 2 years, she's now been promoted to a 主任工程师, so she can do something very different. So I will invite her maybe 10 to 20 minutes to tell you 3 things. Okay, the first one is how did she get hired? What she have the questions during the interview, and second one, what did she do in the department of device engineer? And the third one is what is the key to survive, even thrive, being a successful engineer based on her experience for the last 2 years. Okay, so if you have any question, be prepared to raise your hand, and she will be free for any questions. She's from Vietnam, so if you can also speak Vietnamese, you are welcome. Okay, okay. Let's welcome. I'm here.
Hello, thank you for Professor to invite me today. So 2 years before, I just graduated from DOB NCU, and Professor is my advisor. Yeah. So after that, I also sent my CV to many companies, but finally I just got only one offer, and only one interview and one offer from PMC, where I'm working now. So that's the answer for the first question. Why did I go to PMC? Because I just got only one selection. At that moment, the only one that chose me to become an engineer. But I want to say that after 2 years working in the company, if in the future, 1 year after this moment, and you graduate and you want to choose a job, how can you find a good job? So maybe you can depends on 5 different points when you receive the offer. So I will go to the key points right now. So when you send your CV to a lot of companies, and maybe you can receive a lot of offers. So how is the main point if you want to find a good job? So the first one is that you need to care about what you can learn from the work. So I can commit the career purpose. So when I come to the TSMC and I'm the device engineer and I can work whatever I want, is the power transistor. That is the most I want to do when I'm in the school, but I haven't got any chance to do it, and I already can do it when I come to the TSMC. And the second, and also I think also the very important thing is the salary. And because the salary, please don't forget all the benefits. Because maybe your salary is not very high, but all the benefits can compensate the salary. So the third one is that the very important is that your team member and also the leader. So in the beginning, when you do the interview, it's not only they interview you, but also the chance that you can make the connection or make the first choice that you and the team member, the team leader is fit or not, is also very important. So the fourth is the working culture or the working environment. Because and you may hear something about PMC. It's famous for the work-life balance. And I said it's true. So you can do a work-life balance in the PMC, and it's very fit for myself. So and the 5 is the working place. Because you know that you can choose the place where you want to live. For example, somebody want to live in Taoyuan, and another want to live in very famous and noisy place in something like Taipei. But somebody wants to grow too many semiconductors. industry company, so you choose to live in Hsinchu. So yeah, that's where I live now, Hsinchu. So when you got the offer, you can check the 5 key points here and evaluate if the offer is fit to you or not. Yeah, it's the first question. So why did I go to PMC? It's very happy to me that now after 2 years, it's also okay with this 5 key points. So it's the first question Professor Rati to me, and the second question is about what I do, what is my main job in the PMC. So as a device engineer in the TV department, also the second question. So I do the device engineer. So what do you know about the device? Something like the transistor. Yeah, so I'm doing something related to the transistor. It's a power transistor. Something you want to use to control the power, turn off, turn on, change the DC signal to the non-DC signal with different voltage, or the DC to AC, AC to AC, something like that. So I do something related to the power transistor. And you may be going deep inside is the gallium nitride hand structure. If somebody is doing this study related to the gallium nitride material, that's what I'm doing. So my main job is that we have the device on wafer. So we have so many devices on wafer, and we already do some simple tests to know that the device is good or not. Some simple tests like the IB test or the CB test you may know in your experiment test, in experiment post. And after that, if you want to know that the device is good or not, okay, so good or not, you need to do some advanced testing. So that's what I'm doing here. So I will do some advanced testing to make sure the device is good or not. And after that, our team will do some suggestions to make the device improvement. Okay, so maybe it's totally not much different in the school time. So you also do some experiment. And also need to read some papers, some pattern, to explain your result and also to get some new idea about how to do the device improvement. Yeah, that's what I'm doing day by day, like week by week. So in one day, I just come to the company, and the first thing that I will check all the results that I did yesterday, and I will follow the next testing schedule to know what I need to do today, and the next time is that do the experiment, and next analyze the result I got, and reading paper pattern, and do the report, and in the report we will have some suggestion for the future improvement. Now that's the whole day schedule, and also I also need some time to take a rest, the lunch, and also the practice. Yeah, it will include it. And next we will have the third one. It's just my personal experience. Maybe it's not fit to everybody, but we just exchange the idea. Maybe after I finish my talk, you can take a questions, and we can change the idea. So the third one is that if you want to survive in the company, it's not very hard as you think. Yeah, it is not very hard. So if you want to survive in the company, I think the most important thing that you need to know how to communicate. Yeah, it's very important to know that what you need to do and what your boss needs to get from your result, and what is your team need to do to finish your KPI. Yeah, that's all about communication. So the second is that the management. So I will say it's the time and energy So time and energy management. So you may be very familiar with the time management that you want to do everything very efficiently to save your time for your own daily work, for example, relax or something. But a new thing is that the energy management. You also need to know how to do the energy management. You need to know how is that work. You need to put 50% of your energy today, and the less important, you just make it move at itself, something like that. So it's very important. And the third is that you need I don't know how to say it in English, but because when you are a student, you will think like a student. But you move to the company, that's a big change, and now you become an engineer. So you need to change your mind from the student mode to the engineer mode, yeah, something like that. For example, if you are a student and professor told you that you need to finish your homework unless you cannot pass the course or something. But in the company as an engineer, it's not 100% like this case. You can, for example, you have a problem, and maybe the problem cannot 100% be solved at that time. It's something like that. Maybe Q&A question can help us to make it more clear. Yeah, that is what I want to say today about three parts. First is that you want the offer and what you need to think about. And the second, what I'm doing at my engineer working day. And the third one is the key skill to survive in the company as an engineer. Yeah, that's all. Yeah, 10 minutes. Okay, so we still have time for the Q&A section.
Do you speak English or Chinese in the company?
Most.
Both?
Yeah.
Which one is more?
Maybe Chinese.
Chinese?
Yeah.
Okay.
Fortunately, in my company, because we still have the international worker, so we still need to do the PPT presentation in English. But in order, for example, the experiment or the interact, so yeah, in Chinese, sorry. So now if you have a question, you can ask me in English, in Chinese, and maybe Vietnamese also. Yeah, but yeah, I will try my best to answer your question. So don't be shy.
有没有问题？
Yeah, it's the same.
Question.
Yeah, it's the same when I sit in the class, no questions. Okay, please.
Then I have a question for you, but I know you are a Vietnamese student, so you're learning dual program from half of Vietnam and half of Taiwan, right?
Oh.
So did you spend many years to learn Chinese now? Can I know yes?
Okay, so let me answer this question about how I learn Chinese. Maybe it is not fit to the Taiwanese student, but I'm still answering this question. So I came here in 2018, so it's already 8 years. Yeah, I spent 2 years for the master degree, and after that, 4.5 years for the PhD degree. So in that period, in the first 2 years, I cannot speak any Chinese word, just very simple, 谢谢, 你好. And every Taiwanese student will say to me, oh, 你中文很好. 但我觉得不是，就是只有2个，谢谢你好. Yeah, and after that, when I start my PhD degree, and I just recognize that I need to learn Chinese, because when I just only use English, I just feel that something is missing. Yeah, so start from that moment, I start to learn Chinese. So first step, I just learn Chinese by the course from our school in the language center, because they provide the course free, so you can learn whatever you want. At that moment, I learned 2 Chinese course per semester. Yeah, and this is the first thing. And the second thing is that I will chat with my lab mate in Chinese, and they will answer me in English. and one needs to improve English, and one needs to improve Chinese, and we just work together, and after that both become better. Yeah. After all, yeah, I think maybe I also watch the movie and also the show in Chinese. And thanks for everything. After maybe 3 or 4 years, I can use my Chinese to communicate with the order. Just not just only by some bubble tea. Yeah. Okay, so it fit yours.
Yes, sir.
Okay, yeah, thank you. So is there any order?
以后你们在公司看到的外国人可能越来越多。
因为少子化的关系，我们现在从学校开始，对不对？学校的外国学生会越来越多，因为大家到外面招生，那这些外国学生毕业之后都会留在台湾工作，所以我们说要有国际视野，不一定要出国，是你要知道怎么样跟外国人沟通，因为每个人讲话的方式或是他们的习惯文化不太一样。所以他讲的这3点，你们听得懂吗？这5点就是你收到 offer 的时候，如果是不同公司的 offer， 你要选哪一家，对不对？那通常就是考虑这5点。第一个当然是通常大家会看薪水，对不对？他说除了看薪水以外，还要看什么？看福利，福利包括你的工时啊，几点到几点走，然后放假的时间，或者是有什么社团。What's the working hours of your job?
8 to 5.
8 to 5. See? 在第7天就是8点到5点。No over working.
We usually will have the working time 8 to 5, and we also have the half hour of flexible.
Yes.
So you can come at 8:30, and you can leave at 5:30. Yeah.
Okay, usually you leave around 5:30 and 5.
Yes, you can
Okay.
leave at, yeah.
所以在第7天，它的薪水可能没有那么高，跟台积电比。可是台积电通常不太可能5点半以前离开。好，那就是大家要选择一下，对不对？那当然就是你去这个公司的目的是什么？你要学什么东西，或是你只是想要赚钱而已，然后可以少一点个人的时间。每个人的想法不一样，对不对？好，所以不是一窝蜂。哦，那当然就是你的同事长什么样子，这个你在面试的时候可以问一下。What's your team? So how many team members do you have for your company?
It's just only my team for the game device is 5%.
5%.
Yeah.
Okay. So in the less famous company, your team is usually smaller, which will make things simpler. You don't need to interact with many different people, which can be challenging sometimes. So that's a difference. Bigger company, new company, or small company. Okay? And working culture, you can also ask when you are going through the interview, right? And working place, take a look. What's it like your office or the room? Okay? And the second bit is the working items. What did you do in this job? Because the bigger company usually it is separated into different divisions. 它有不同的部门，对不对？台积电的部门就超级多，它有这个整合、制程整合，或是蚀刻，或是布光协议，或是设备，或是人资。所以每一个部门的那个工时啊，或是它的文化，或是它要求的这些专业能力可能都不太一样，对不对？好 ，OK。第3个问题，我就是要跟大家分享，怎么样可以在公司活下来，甚至成功。他讲的第一个是什么 ？Communication。Okay, what do you mean by communication? Okay, not your expertise. Communication, in other words, don't speak the words making people angry. Okay, efficiently, politely. Okay, 好，所以不要很容易把人家惹毛，这个是基本的。可是通常大家在一个公司里面遇到问题，通常遇到第一个反应是什么？这不是我的问题啊，这个是制程的啊，这个是累积的啊，这个是品管的啊，大家一定会推，对不对？可是如果是问题 你要推还是要看一下是谁可以解决。所以这个东西长久以来，大家就会给你一个刻板的印象，或者是你给人家的人设。这个人遇到问题是会去帮你解决，还是就躲不远的？这个是 communication 很重要。Okay, second one to survive in the company. Learn how to schedule your time, your working and your energy. OK， 怎么样去安排你自己的时间，还有体力，这个很重要。比如说，昨天我跟一个学生各密，对不对 ？OK， 准备了非常多的 data，a lot of data, measurement results, and the device verification conditions. However, whenever I ask him any question, he gave me no response. Just sitting there without saying yes or no. After 10 minutes, I was so angry because I got no response from his results, although he showed me a lot of PPT. And finally, I asked him, what should we do to make it better? He still gave me no response. 做了很多，当我要跟他讨论的时候，要怎么调整，要怎么样让这些量测数据更好的时候，他完全没反应诶，不知道。后来我就受不了了，就说那你下礼拜再来找我，这样子我没办法跟你讨论。早上的时候他就跟我道歉了，他说老师，因为我昨天晚上几乎没有睡觉，所以他到下午来找我讨论的时候已经恍神了，他可能今天都在赶那些量测的东西，或者是做支撑。In this case, if you have no sleep last night, don't schedule an important meeting, especially with your boss. Otherwise, you will piss them off. Unless you have no choice. If you have no choice, you got to make sure you have enough energy to speak something useful, especially before your boss. Also, with your partners. Don't give no response, right? Because whenever the boss is meeting you, he expected you to give him some feedback, useful feedback information. Okay, otherwise you are wasting his time, right? Did you report to your boss often?
Yes, every day.
Every day? How long?
In our team, we have the culture that we will have the morning meeting every morning. Yes, of course. And 1 week for the weekly meeting. And the morning meeting maybe just take about 10 minutes for 4 person. So it's very quick and neat. We just said today what we need to do. And if
10 minutes for 4%?
yes, so it's very efficiency. So
and
just
8 minutes?
yeah.
Which
So.
one?
Yes, what we need to do today, and if you have some problem, you need your boss to have, and you need to speak up, and that's all, finished.
Okay.
Yeah, because in the company, they might, especially your boss and also your college, don't have so much time to listen for your things. Because you think that's important to yourself, but not important to all the person in your team. So yeah, you need to catch the time. So it is the meaning of the time management also in the presentation. And especially in my community, it is not but for the TNMC. For your report, it needs to be 1 page. Just only 1 page for a report. So yeah, you need to select what is the important thing and yeah, just report the important part. So save your time and also save your time.
Okay. 1 page, 2.5 minutes. That's it.
It is also the condition, the standard for the NVIDIA or some big company about the presentation.
I had the same thing from a professor who used to work in TSMC. He is an IT engineer. He said when he report to his boss, 3 minutes. Okay, nothing else. If you cannot speak the key message, making your boss agree with your decision, then that's it. You have no chance. 知道吗？每天只有2.5分钟一张投影片的机会。不管你是在力积电、在台积电、在 NVIDIA， 几乎都是这样子，因为老板没有时间听你讲细节了，你只能告诉他什么是最重要，你需要他什么资源。OK， OK，所以在学校的时候跟老师 meeting 要把握这个练习的机会，老师通常会愿意多给你一些时间嘛，对不对？可是当你在跟老师，尤其是在1对1 meeting 的时候，看老师觉得不想再搞什么鬼，那以后你去公司一定更惨嘛。如果是很重要的 meeting，你前一个晚上又没有睡觉，那看可不可以延期？那不然你最好前一个晚上好好睡觉，因为你没有表现，总比表现很差还要好。表现很差就是洗掉就可以了，对不对？OK。
Yeah, it's also the third point that I just write down here. So in the school, you can accuse because your professor is very nice, but in the company it's totally different. Yeah.
Mindset,
So
that's the mind 心态。
yes, so you need to change your mood that you are an engineer and maybe you are a very professional engineer and you need to work like a professional engineer. You are not just a student or a good student anymore. I think the time is somewhat so maybe we still have time for the last question.
Any questions？有没有问题？
Yeah, so yeah, something like this, you waste your time, yeah, and also your opportunity to interact with the industry company. Yeah. So
你会推荐新人去台积啊，去立积电吗？Yes or no？
no, because I'm not sure about them thinking. Because as you see here, no voice from the other side. Yeah, so I don't know and I don't have any recommendation.
If someone asks you, I got an offer from TSMC.
So yeah, the first question is that do you got another offer or just only one? So because if just only one, it's the same as my case, so I don't have any choice. Yeah. So yeah, it's the thinking of the engineer. So if you have a problem and you need to solve it, but you don't have any problem, so don't create a new problem. Is it okay?
OK，没有，他就要回去了，我们就要上课了。OK。
Okay, so yeah, thank you for your listening. Yeah. Maybe you can hope to see you in PNC someday in the future. Yeah, maybe you still have. Thank you.
See you next time. 好。有没有什么问题？没有问题哈。其实他是2024年5月拿到立积电的 offer， 可是他6月又收到一个 interview 的邀请，是世界先进。那时候他就说要不要等？如果我那时候是跟他说，其实可以去立积电，为什么？因为立积电那时候只有5、6个人，一个新的部门而已，就是做 power device。OK， 年轻人。 假设你不是很缺钱的话，其实你工作的内容比薪水对我来讲还要重要，因为薪水大家知道现在的行情啊，如果你只是看月薪，大概就是6万到8万之间，最多大概差2万。那当然，现在台积电听说很夸张，第1年可以到250万，就是绩效奖金。对，可是去台积电的问题就是，你可以做的东西可能就是会比较被制约，因为它公司很大嘛，所以每个工作的条件就非常的很细，就不一定很细。那如果是一个新的部门 ，new department，you don't have so many rules, so you have more freedom to do whatever you like, although you don't have as much salary. So that's a trade-off. You want more money, or you want more chance to learn. To me, more chance to learn is much more important as a young engineer, especially for the first job in your career. You got to learn as much as you can, so you can have a better offer for the next job. Because most of us will have more than one job in our whole life, right? So the first job is for you to learn, not for you to make a fortune, because we all need to learn something for the better future, right? 所以我觉得第一份工作，除非你是要帮家里还债，那个是特殊情况。第一份工作通常是看你的学习的机会。那小公司当然比较不稳定，或是薪水比较少，或是小的部门。可是小的部门通常你可以学、可以看的东西会比较多，因为它没有这么多很严谨的规定，很多规定都还没有出来，甚至要靠你去制定。那个时候你就有机会去学不同的东西。你有这些不同的经验的话，下一份工作你就比较有好的条件可以谈，对不对？所以他现在去不到2年，对不对？快2年了，已经变成主任工程师了，影响很大。可是主任工程师他管的可能就是5、6个，可是在台积电你不太可能2年变成主任工程师啊。虽然台积电的主任工程师跟力积电的主任工程师差很多，可是对一个新人来讲，我觉得如果你有机会当那个主任工程师，在年轻的时候可以学很多东西。对，好。It's not that always small company is good, but you need to think about what you want to become when you are 30 years old, when you are 40 years old, when you are 50 years old. Because this milestone depends on what you have learned in the first few years, which is the key. Okay, because the initial salary, you don't see much change. It's just a matter of 10,000. Right? 起薪通常就是差不多，对不对？1、2万，不会超过10万。对。可是你到40岁、50岁，甚至60岁的退休金，知道那个薪水差多少吗？同样都是中央光电毕业的，同样都是台大毕业的。如果你在30岁之前做的选择跟人家不一样，你在60岁的退休金可能就会跟别人差，就绝对不是1个月1、2万块而已。看一下那些开同学会的人，对不对？所以第一份工作，大家好好想一下，尤其是年轻的时候 ，you have nothing to lose, right? Unless you need to support your family, but if you are young, no family, you can only consider yourself. Just think what is the most important for yourself. I believe it's not just only about the money, it's about what you can become in the future. 好啦，讲完了，回来上课。OK。So in the midterm, I give you a question during my class, and in the class I didn't give you the answer, right? I was thinking about if some students will come ask me for the same question, so I can tell you the answer. Okay, the question is, will the Fermi level change at a different temperature? Did you still remember the question? Yes? But do you know how many students come to ask me the same question before midterm? Only one. I believe he is the one got the answer right, right? So in the midterm, I give you 3 Venn diagram, right? 3 Venn diagram at a different temperature. So this is the conduction band on the top, valence band in the bottom, right? So the freezing temperature is 0K, 150K, and 300K, right? So I give you a hint of the band feeding condition at 3 temperature, right? So if you have a 0K, absolute 0 degree, all of the energy levels below the Fermi level are 100% filled, right? So it's all filled. So it's 100% filled. And above the Fermi level is 0% filled, right? So where is the Fermi level? In the middle, right? And the the distance between the edge of the conduction band and the valence band should be the same. Right? Otherwise, you cannot maintain the chance of 50%. Right? So here is the 50% of a band filling. Right? That's the definition of a Fermi level. So if the band gap is 3 electron volts, this should be 1.5 electron volts. 1.5 electron volts. Right? That is what I'm looking for your answer. How about if you increase the temperature to 150? What is the change of the band filling? You know, when your temperature is above 0 K, you have more or less electrons excited from the valence band to the conduction band, right? So here you will have the top valence bands be empty by the thermal excitation, and the bottom of the conduction band will be filled. Right? For example, if you have a 90% fill at 150, because 0 K is 100%, but at 150, some of the electrons goes up to the conduction band, so it is less fill as compared with the 0 K situation. And then here you have a 10% because all the electrons fill the conduction band are from valence band, right? So the band filling is only 10%. Right? So that's the information I give you in the question. So what is the position of the Fermi level? No change. Still in the middle. Right? Because you need to make sure this energy level, if it is right in the same position of the Fermi level, what is the percentage of the band filling? 50% all the time. Right? No changes, still 1.5, 1.5. Now you know the answer of this condition, right? Where is the Fermi level? Same position. Because all of the band filling in the conduction band are all from the valence band, right? So it's still here. The only difference is that you have a less band filling, maybe 80% fill, because of the higher temperature. So 20% are filled in the conduction band. So the answer actually is pretty easy. You don't see any change by simply raising the temperature. In other words, temperature change give you no change in the Fermi level. Your change in the Fermi level does not change with temperature. Okay? So what will change the Fermi level? Doping, right? So, for example, if you dope the semiconductor at the room temperature, then we are talking about the N-type of doping, right? So at the 300 K, N-type. So what will change? N-type, you will have a donor incorporated in your semiconductor, right? So you have one additional energy level, which is called donor level, right? Donor level is introduced by the impurity, right? So this donor level will change the band filling condition in the valence band and the conduction. If you compare the situation with N-type of doping and non-doping, you know how to make the difference. If you have a non-doping, this Fermi level in the middle of the band gap, and the band filling is only 80% in the valence band. what will this change when you have unpacked doping? More than 80 or less than 80? Okay. More or less? We talk about this in the class, right? Remember the 12 figures, 12张图，对不对？当你变成一个 untype 的动的时候 ，how much will change in the reduction in the balance band? The band filling will become even less. Let me see. Okay. You will have a maybe 95% field. Because if you have untyped doping, the electrons in the valence band will have more challenge, more energy barrier to be excited to the conduction band. In other words, if you have untyped doping, electrons in the valence band are more unlikely, less likely, more difficult. Okay? Because the donor level will fill up the bottom of the conduction band easily. So it will become 30% filled. I just give you the language to make you understand it more easily. Okay? Why you become 100% filled to 30% filled? This 10% additional band filling is due to the contribution of the impurity level of the donor level, right? This is the purpose of donor level to donate additional electrons to the conduction band. So originally it is only 100% filled. And because of the untyped doping, it becomes 30% filled. So this 30% will make the semiconductor untyped, which means you have more electrons than holes. Okay, so the total of the percentage is no longer only 100%. It's more than 100%. Why? Because you have an additional source of electrons, right? So in this case, where is the Fermi level? Where is the Fermi level? It will not longer be sitting in the middle of the band gap, right? Because Fermi level is to maintain the percentage of band filling to be 50. It's always 50% filled if the energy level is at the Fermi level, right? In order to maintain the 50% of the band filling, you need to make the Fermi level to here. Right? Because this is what I told you. If you go back to the 0 degree, all of the Fermi level, all the energy level below Fermi level will be 100% filled, which means the donor level will also be filled 100%. All the electrons will go back to the valence band or to the donor level. So every energy state, every energy level above the Fermi level at the 0K will be empty, 0% at the 0K. Right? So usually the Fermi level is between the conduction band edge and the impurity level. Right? How about you increase the doping concentration? This is low untyped doping, right? Say this is low. How about high? High means from 30% to 40%. Even higher. and your donor level will not change because it is the same impurity, right? If you just increase the concentration without changing the doping atoms, right? For example, if this is silicon, that type of doping is mostly by phosphorus, right? If you use the same phosphorus, but just with increased concentration, it just makes the band density higher. You have a more energy dense. You have a more energy dense here. Okay, you still have the same donor level at the same position. This position of the Fermi level is only determined by the type of impurity. If your impurity type has not changed, you change nothing about the position of the donor level, right? 它只取决于你的doping的种类而已。如果你都是用磷来产生doping，那这个donor level的位置不会变，除非你改成用其他的元素来做doping。Right? So in this case, if you move from the low doping, for example, 10 to the 17, and then you become 10 to the 18, right? You change the band filling again. This one is 95%. How about this one at high doping? Do you know how it will change? It will become even more difficult for the electron to go from the valence band to the conduction band. So the band filling at higher doping will become even higher, right? Maybe 98%. Why? Because electrons here is not able to find an empty space in the conduction band. Why? Because all the initial conduction band levels are already occupied by the electrons from the donor level. Right? Electron is more easily to go from the donor level to the conduction band because the energy barrier is smaller compared to the energy barrier from valence band to the conduction band. Right? So this is 40%, this is 85%, 89%, 98%. So the total band filling is much higher. Why? Because of the high untangled doping. So in order to maintain the 50% of band filling, which is the definition of a Fermi level, you need to move the Fermi level even higher because you can find an empty energy space easily at higher energy levels, right? So the Fermi level will move even higher. In the band gap, right? I'm just to tell you, temperature alone do not change the Fermi level position. You change the Fermi level by doping, not by temperature. So you agree? Okay, I hope you got the answer right. Okay. Let's take a break. We'll continue the work 10 minutes.
再讲一次，再讲一次。再讲一次。多的浓度高的高的，你不管是。
这礼拜我应该没有打球，下礼拜我。